What is up? We are live. We are on YouTube. It is Wednesday. It is Premed Q&A. Let's get everybody a chance to get on here and get with us. We are live on YouTube. Guys, I'm so excited to be with you again tonight. Do I look as tired as I feel? I have not been sleeping a lot lately, guys. Between work and the baby, it is crazy around here, but I'm glad I get on here with you guys tonight. It's Wednesday. Jocelyn, what's up? Lave, what is up? All right, so tonight, what did I say the topic was, guys? What up? What is it? Matab, Kasim, what is up? Dan, who is this? Melanie, basic book nerd. I kind of like that. Yesenia, what is up? Yesenia, you just enrolled in... No, Yesenia, you just dropped a review today. I appreciate that review on my MCAT course. You enrolled in my MCAT course earlier this month. I'm glad you're loving it. If you guys haven't, get over to my website, premedproductivity.com. Check out Yesenia's review of my MCAT course. It's pretty spot on. It's amazing. But so tonight, we are talking about how you guys can get at chemistry and physics. So the title of this video is Why You Suck at Chemistry and Physics and Why Your Stank Ass is Not Going to Get into medical school because of it. So some of you guys catching this first time stream, bonjour, bonjour. I like that. So here we go. Why do you suck at chemistry and physics? Why are you not going to get into medical school because of it? Why? Let's break it down. So, very first up. So, I have to, in the last 2 minutes, I put together this flashcard just so I could have some basic semblance of points. Anyone who's ever met with me in person knows I can get on tangents real quick So, Utham, what is up? So, I have to kind of get it together and have at least a couple bullet points now to be able to get us going and keep the group rolling. So, thank you guys very, very much for joining me. If this is your first time joining us, welcome. I'm Dr. Pinesett, the Premed Productivity expert, and every Wednesday, 7-ish, 7:30, we do these live Q&As. We'll lecture. I'll talk about some topic that'll help you get to medical school, and then I'll answer your guys' questions for however long I have, depending on the day. So here we go. So number one, why do you suck at chemistry and physics? Well, the first reason you suck at chemistry and physics is because you tie your whole educational being to grades. And this is why you guys get all caught up in, do I have the prereqs for the MCAT, and I need to take this course before I take the MCAT because it's on the MCAT, and all these kind of things. You guys think an A in a class makes you knowledgeable. You think an A in a class means that you know something. When in actuality, I would tell you an A in a class means absolutely nothing. And it's the same reason, right? People have difficulty transitioning from college to real jobs, is all that garbage you teach you in class is nothing. Because all you've done is memorize it at a basic level. And you focused on, I'm gonna get those A's, I'm gonna get those A's, I'm gonna get those A's. Instead of focusing on actually understanding the content. So the very first thing you have to change up, if you wanna be great at chemistry and great at physics, is you have to seek understanding. It's entirely different. And C. Charles said it right, he's in my class, so he knows what's up. Theory versus application. You gotta take yourself from, I memorized the theory, I got it, gravity. Oh, I got it, there's a periodic table, and there's a bunch of elements on it, and the elements get together, and they form stuff. Chemistry, right? From the theory to taking it to application. And actually, how do you use those concepts to your advantage and apply them in unique and different and novel situations? See, Charles is on fire tonight, I like it. Book life versus real life, true story, right? The test is real life, your homework is book life. So you gotta go to that real life bucket. So the first thing, change it, guys. I know you think that when you go into that quiz, right, every week you got a weekly quiz, and you get 9 out of 10, you feel like you're doing something. But I would challenge you guys, instead of focusing on that quiz, really, truly, and you guys know this, right? Tell me if I'm wrong, but tell me in you guys' hearts, have you ever gotten 100% on the test, or like a really good score on a quiz, and you're like, whew, I don't know how I got that, because I really don't understand anything, right? Or you can't fathom, or you get everything right, and you're like, yeah, but I still don't know it. I just kind of guessed right, and all these kind of things. And you guys are satisfied with that so frequently, where you're like, oh, it's all right, I got through. I got through. I survived. I got through. They didn't catch me up this time. Live to fight another day, and that's how you go about it. And so when you do that repeatedly, what are you left with? All these buckets of defunct knowledge where you got the grade or almost the grade and you settled on it and you didn't have that understanding. So then you get to the next level and it's that much harder. And this happens to people right in transition. Okay, chemistry 1A went great. Then you get chemistry 1B, ooh, it didn't go so great. Then you get chemistry 1C and it's awful. And you can't figure out why you're getting worse every quarter over quarter. Well, your principles aren't sound in 1A, they're not sound in 1B, so then in 1C you're a catastrophe. That's how it goes. And it's because you didn't seek understanding, you focused on just the grade. Just gotta be good enough for the whatever grade. You gotta go beyond that. So that's number one, right? So seeking understanding and not the grade. And that's kind of amorphous for some of you guys, right, who are new to me. But if you didn't understand that example about the test score, right, and you getting that 9, but you knowing in your heart that you don't know it, we're going to get to some examples and we'll talk about what that understanding level is and what I mean in understanding briefly. So, number 2, you need to prepare for your lecture. So a lot of you guys roll up to lecture and assume, and this goes back to, again, I hate the educational system because they teach you guys all wrong. You assume that the teacher is there, right, and they're going to teach you everything you need to know, and you don't need to learn anything else other than what the teacher gives you. And so you think, I'm going to go to class, go to lecture, I'm going to sit down, and this teacher's going to give me all this great information, and then I'm good to go. And that's my starting point for studying. And I would actually argue the contrary to that. Roberto, what is up, man? How's it going? How's the East Coast life treating you? Roberto's one of my students. He's over at Harvard right now, hanging out, chilling. So hope everything is well with you and your family. And again, the family situation going on, hope that's working out all right. But anyway, so preparing for lecture. Lecture should not be the first time you're exposed to material. It should absolutely not be the first time you're exposed to material. Why? For a couple reasons. One, when we are seeking understanding, true understanding and useful understanding that goes into application comes from the struggle, that comes from your struggle, and then from that struggle and that difficulty you have when you approach the material without guidance from other people, you develop your own understanding. And the common knowledge way of this is, you ever walked into a room, right? And if no one says anything to you, you're making assumptions about everybody in the room. You're developing your own understanding of the room. Thank you for that goatee. Thank you, Jacob. I had to shave the beard a little bit. My wife was getting on me. So she said, get that beard out of here. Get a goatee going. So goatee is here. But you have to take it to that next step, right? Of understanding yourself, that struggle of internalizing in your own mind and making your own assumptions about the material. And let me know if this is some of you guys, where you guys will be taught something, right? A tutor will go over something with you, or the teacher will go over something and make perfect sense. And then you get home and you're by yourself, and what happens? Wait, what? What? Wait a minute. What was he saying? Wait, what? What? And you don't have enough understanding to really get at it. And this is so common with students, and they misuse tutors, they misuse study groups, and they misuse lecture, and they're relying on other people to give them that first piece of knowledge, and they feel like, oh yeah, I've got it. It makes perfect sense when someone explains it, steps 1 through 4, and then when you get home, you've got nothing. And it's the same thing that happens on your tests. You go to lecture, you feel good about it, right? You do the quiz, you feel good about it, then you actually get to the real test, and the real stuff starts hitting you, and you have no clue what to do. No clue whatsoever what to do. So you've got to, before lecture, you got to prepare. When I say prepare, I mean you got to be in your book, you got to be in your resources, watching videos, whatever it might be, preparing and having a solid foundation. Like a thorough foundation, more thorough than you've ever had for any test day. You'd have that kind of understanding of the material before lecture. So you prepare for lecture hard. And then you do all this prep work up front in front of lecture. And then when you get to lecture, all you do, right? Because if it's an arithmetic, we're talking about arithmetic-based classes. So with an arithmetic-based class, this works for, so let's take a step back. The way I teach you guys to do stuff is I want you guys to have systems that are universally applicable across the board. So my study course is amazing because it's 5 pillars that can serve you well in any type of class. Okay? So what I'm teaching you right now are some of the basic things that I teach in that course for arithmetic specifically. And they work the same for biology and non-arithmetic based specialties, but this works for chemistry, physics, math, all these kind of things. So you prepare before lecture, get all the foundation in. Then when you get to lecture, and you guys think about how your chemistry classes and your physics classes are taught, right? Typically, this is one of the few classes where the teacher will get on the projector or the overhead, or they'll have some computer program, and they diagram out examples, and they walk through problems with you guys, right? Who's ever been to a chemistry lecture, a physics lecture, and that's what they're doing, right? They're going through examples. The problem is, if you haven't gone through the material and learned the principles and the foundations, you can't get the most out of those example sections, because you're just now like, wait, what? What is an atom? Wait, gravity, what? And you're sitting there at that basic level, and you can't even start to really comprehend and think about what they're doing in terms of their equations and problems and examples. So by preparing a lot in advance, then you get to the lecture, and now all that knowledge you have, all you're doing is refining it in the form of those examples. And now you're getting all the juiciness from that class, right? Where you can, right, have a grasp of those examples at a deeper level, and then you can take that home and you can apply that same material to your homework. Does that make sense to people? Give me a like right now if that makes sense to you. I am sweating up a storm. So I was the late resident today, but I actually got off a little early. And I'm always happy when I can get off early because I can get home before bedtime. And so my kid and I were running around the street. We're running. I'm a big guy, so I sweat. So I was out in the street sweating, and then I was like, oh gosh, wait, it's 7:30. Let me get inside and do this video for you guys. So I apologize in advance because I'm sweating. But we had a good time. We played some chase and some hide and seek, and we collected some rocks, so that was good. So anyway, all right. So you prepare for lecture, right? And we get lots of goodness out of those lectures. Then from that lecture, we leave lecture, right? And we got all that goodness, we got that baseline foundation. We then go home and we do our homework. How many of you guys hate when the teacher gives you 100 homework problems? Oh, this is a waste of my time. I gotta do all this homework. Oh my gosh, I'd rather be doing this. Homework's a waste. Like, and why they give me worksheets every week? I hate this stuff. And the reason your teachers are doing that is because they're trying to give you opportunities for practice. They're trying to mandate practice upon you. The problem is you guys see those homework problems as, right, a burden, as an obligation, as something you have to get through for the rest of your day. And because you approach it that way, right, it's like a chore, right? Whenever you do a chore, clean up your room. How do you do it, right? You grab all the clothes and you shove them under the bed. Because that's the quickest, right, easiest way to get done with cleaning your room so you can go out with your friends. And some of you guys treat homework problems in arithmetic-based classes like chemistry and physics and math the same way. I should get through them as fast as I can, bang them out so that way I can get to my real studying or I can get to my friends or whatever it might be. So what I want you to do is, first of all, is take a different approach to homework and not look at it as an obstacle to your learning. Not look at it as an obstacle to your friends, but look at it as a gateway to your learning and as a gateway to your friends. Because if you're taking the homework assignments and instead of just breezing through it super fast, if you take your time and you try to get everything you can out of those homework problems and ask yourself, we're going to talk about this in a second, how you can suck all the juice out of every single problem, all the learning out of every single problem, what you'll do is you'll find that even though it'll take you longer to do your homework, you'll spend less time studying because all that struggle is great learning. And all those problems you have to do anyway now become functional studying and not just something you have to do. Then, right, when you do that, right, and even though you're spending more time up front, all that time is well spent, the quality of that time, right? And all these are coming together. Oh, yes, I'm getting all these concepts. You'll spend less time studying, so then what do you have more time to do? Hang out with your friends. So by putting more effort into those homework problems, you'll have better studying. You'll have less of the studying to have to do, right? Active learning. So you can tell C. Charles is one of my peeps because he's on here. He knows what's up. This is all basic math for him, right? He's like, man, this is like slide number 3 in our course, right? This is basic stuff. So you'll be more active and you'll get more stuff done and then you'll have more time for your friends. So it's a gateway. So for me, when I saw homework problems, anytime I had a chance, I'm doing homework problems. And the way you approach your homework problems, let me talk about that. So first of all, when you have your homework problems, when you have each of these problems, I don't want you to just, and I'm gonna give you some examples in a second, but I don't want you just to do the homework problems as they are. I want you to look for additional learning opportunities beyond just the superficial, basic topic that the question is asking. And I'll show you an example in a second, but you have to go beyond that to find what other related points are gonna be there, and then what other testable elements of that topic are there that could possibly show up on a test. And by doing that, right, you're expanding your base of knowledge, but you're also expanding how you weave through the different material, and you'll have a more fluid and applicable, right, knowledge of the material. So doing that. The second thing you're gonna do is I want you to go beyond just the homework assignment. So if you get assigned 10 problems for homework, I want you to do 15. I want you to do 20. I want you to do 40. I want you to do 50. And if you can do those many problems, right, and you guys can attest to this, think about the classes where you spent more time doing more problems. Did you not get a better grade? Did you not feel more comfortable? Did you not feel more confident? Then why don't you do that in all your classes? Of course you did, right? Why don't you do that in all your classes? Because, right, it's painful to do it. But if you do it and you get results from it, then why do you stop doing it? Why do you settle for just doing the bare minimum? So you've got to go beyond that and think, okay, if everyone else is doing 10 problems, and everyone else is doing these 10 problems, they're gonna have a good understanding of these 10 problems. if I'm a teacher and I'm a test writer, will I test you on those 10 problems, or will I test you on problem number 15 or problem number 20? Or bring together those concepts in a way that goes beyond what you would understand in that basic assignment. And for some of you guys, this happens, right? Where you do well on the quizzes, you do well on the homework, and you get to the test, and you get smoked. And what do you say? Oh, that teacher's so unfair. There is nothing like this in the homework. There is nothing like this in the quiz. Of course there's not. It would be stupid. I'd be a dumb teacher to put the same exact thing on my test that I put in my homework assignment. Because that means that every student who's even an average student who just did the homework would have a chance of getting my test 100% right. Instead, what I'm going to do is I'm going to be tricky and do question number 11. That'll be the exact, and some of you guys have seen this, right? In physics, this is very common, where you'll go through all the questions and then legitimately you'll be walking out of the, you'll do all the homework assignments, you'll go to the test, you'll do the test, and you're like, man, that was hard. There was nothing like that on any of the homeworks. And then you'll overhear somebody talking like, oh man, yeah, that was just like problem number 17 on that homework set where we only do number 10, but luckily I went to 17 and it was the exact problem from the book. Oh my gosh. And you're like, mother, right? And you're all upset. But you should be upset at yourself because you didn't go beyond. So as we talk about on this channel all the time, guys, it's about going beyond what other people are doing, going beyond the average, beyond the convention. And when you go beyond that, right, you become the exception and you become exceptional. So you've got to do more questions than everybody else is doing. You've got to be hungrier than what everyone else is doing. And for anybody who's been to some of my lectures, or if you're in my study course, you guys have seen how I walk through the biochemistry notes section, right? And I read in my notes all these times, making them crisper and tighter and better and higher yield and more active. That way I could be the bomb on test day. I go in beyond what everyone else did, so there was no possible way I was going to get fooled on the test. So you guys have to do the same thing in your homework assignments. Okay, so that's homework. So you want to go beyond the scope and do more questions and do the harder questions. Okay, lastly, when you do the questions, we said you're going to go beyond the scope. And so I want to show you guys some examples of this and how we be doing it. So all problems are not created equal. So, excuse me for 1 second. Ooh. All right, all questions not created equal. Okay. When you do questions, you can just say, oh, I did 100 questions, that's great. It's like going to the gym. I love going to the gym because I know how to work out. I don't work out very much anymore, but I love going to the gym because I know how to work out and use equipment, and other people don't. And you guys have seen these videos on YouTube, like where people are using the equipment entirely wrong, or it's just like terrible. You guys have seen this, right? And they're like, why are you on the treadmill running backwards at the incline at 100? Like, you're an idiot. So if you were to do 100 of the proper reps at the gym, right? So you do curls, right? Your arms to your side, right? You got it, bam, bam, right? You're bringing it, everything's flexed, everything's tight, elbows in, right? Versus the guy who's out there doing this with his dumbbells, right? Doing some of this. Or you're doing like those CrossFit pull-ups, those cheating pull-ups so they can do 1,000 reps, right? You're not getting the same burn, the same gain from every single rep. So when you do a question, right, we got to talk about how you extract the most from each question by going beyond the scope. So I'm going to give you guys a couple examples. If you guys are still with me, give me a like right now. Let me know you guys like this stuff. You guys are feeling what I'm saying. Are you feeling it? Are you feeling it? Are you feeling it? Got a bunch of you guys on here tonight. I'm liking it. We are growing every week. I thank you guys very much for being on here every week. It's 7:30, 6:30-ish. Every week you'll see the announcement on my social media. I get it out there for you guys, but we're live on YouTube every Wednesday doing stuff like this, study stuff, MCAT stuff, get to medical school stuff, and then every other Monday, so we weren't on this Monday, but every other Monday on my Facebook page, Premed Productivity Expert, we do Med School Motivation Mondays. This Monday I actually prepared a talk. So we're gonna have a good talk on Monday talking about how I'm elitist, because people keep calling me elitist, so I want to thank you for that, and I'm going to talk about that on Monday, and how you need to be elitist, and how you can become an elitist like me so you can get to medical school. So that's Monday's Med School Motivation, is having that elitist mindset to get there. All right, so I said some examples. Well, that doesn't look good. Let's plus V naught. Okay. Everyone can see that, right? Final velocity equals acceleration over time and the initial speed, right? Plus the initial speed. Everybody see that, right? This is exactly Apollo. I like it. This is a kinematic equation. There are four major ones that you guys memorize. In actuality, there's like close to 15. But those 15 can be simplified into these four, and that's enough physics knowledge for you guys in a basic physics class, and that's why they give them to you. A lot of you guys will say, oh, I'm just going to memorize this equation, and when I memorize this equation, I'll see on the test that I have to use this equation, and I'll put it on there, and I'll be good to go. Right? But the teacher is banking on that you'll stop at just memorizing those four equations, and they're going to be like, yes. Right? And these kinematic equations all go for straight line stuff. So what they'll do is they'll take this basic concept and they'll mask it in a more complex concept. So what they'll do is they'll have like a pendulum, right? And it'll swing, and you'll be super confused about the swing of the pendulum, but that pendulum will hit another ball that's going to go straight there. And so now it becomes a pendulum question with a momentum question with a kinematic equation question, right? And you're like, oh my gosh, what do I do? What do I do? Right? And you'll be super confused if you don't understand the mechanics and have a functional understanding of this equation beyond just memorizing it. Okay? Beyond just memorizing it to it. Who is this person talking about? Subscribe to my channel because someone got tased. They just got blocked. That's terrible. Terrible. I don't understand why people have to get on here and try to sell you guys garbage. We're not on here to get tased, guys. We're trying to get to medical school here. So, V equals AT plus V naught. So we don't stop at basic. We say V, final velocity. So this tells me that this is how fast that object will be moving at the endpoint. So after all the action, all the force, everything's been done to this, this is how fast we'll be moving. Okay, well, what does fast mean? Okay, well, what are the units of fast? Okay, that's right. Change in distance. Excuse me. My pendulum got in the way here. What is the velocity? It's change in distance over change in time, right? Miles per hour, miles per second, meters per second, kilometers per, right? Whatever it might be. So it's change in distance over change in time. So if we break that down, that's point A, right? The difference between point A and point B, and T1, right, and T naught. So where you started, where you went, that's the distance, the initial time, and the time at the end. So now we're breaking it down and we're going and we're seeing, okay, what does this really mean? What is a velocity really? Well, it's how far we moved in how much time. Okay, acceleration, right? What are the units for acceleration? It's change in distance per time. And I know that's not correct how I wrote it out, okay? It's change in distance per time. So it's meters per second, which is a speed per second. So meters per second. Okay, oh, all right, so meters per second. That's acceleration, and that makes sense, right? Because if a speed is how fast I'm traveling, and how fast I'm traveling is distance traveled over time, well then the change in my speed would be how fast I can travel over a period of time. Boom, right? And this is just time. So this now makes sense because, right, change in distance over time over time squared, right? 2 times. These cancel out, and it's just a speed, which is why you can add, right, this speed change plus this speed and get the units of speed. And again, it's just speed over here, right? So this is where you started, how fast you're initially going. You go through all this stuff. Then what happens is you guys will look at this equation and you'll see it as static. And you'll be like, okay, well, if I'm given an initial velocity, acceleration, time, I can solve for velocity. Take it a step further and say, okay, here's the final velocity, here's the initial velocity, what was my acceleration? Take it a step further, take the time out, right? And so even if you have one question that only asks you to solve for the final velocity, you take that one simple homework question and you make it 10 questions by saying, okay, well, forget that. Now let's plug in a velocity, a random velocity. Let's take out acceleration and let's solve for it with a time and a V naught. Okay, then let's put an acceleration here and then check this out and see what happens. And you just play with it and play with it and play with it and fondle that question until you suck all the juice out of that question so there's no other iterations. There's never a question that you get to where you can't get at that question because you've done it every which way 1,000 times compared to everyone else doing it just one way. Does that make sense to everybody? So you take one question and you break the formula, break it down. The why, exactly, one. So see, again, this is how I know my courses are working because my course cats are on here. So Juan's my course. My course cats get on here and be like, yep, because they get this stuff all the time in my course. So they're with it. But yes, does everybody see? So if you do this with every single equation, right? And so people ask me, I'm taking trigonometry-based physics. Does it matter if I haven't had calculus-based physics? And what people don't recognize is calculus-based physics and trigonometry-based physics are the same thing, except for in trigonometry-based or right physics for bio kids, you stay up here. In the physics for the calculus kids, for the engineers, they're going down here. And by going down here, they see at the root how stuff works. And then from that, they can create things, and that's how engineers create things, is they understand the core fundamentals, and they can engineer up and make super fancy things by really, truly understanding the core concepts, not the up here. That's the difference. All right, so the next question. So to find these questions, I just Googled really quick. I said, pre-med questions, and I saw what came up. Okay, these are some of the first ones that came up. The next one that came up was, this is an MCAT question, but it was on the same thing. It was like MCAT / pre-med questions. It said, which element is the most electronegative? Right, so this is chemistry. And the question was, which of these is the most electronegative? And listed 5 elements. I won't even write them down. Okay? If you were to go and do that question in a homework set, you say, okay, which is the most electronegative? What would you do? You would go, right, and you look at your periodic table and look at the arrows and see how electronegativity goes and say, okay, this one, this one is the closest to the tip of the arrow, so it's that one. And you would circle it. But what you didn't do, right, you didn't take the time to actually understand and have a background and a baseline knowledge of actually how to create that trend in your own mind without actually having to see that grid, right? And so for me, one of the keys, I dominated chemistry. I dominated OChem. I was incredible in chemistry. I love chemistry. I was actually, when I started college, I was a chemistry major. And I love chemistry because it's all about math and problem solving and being creative. And so I loved chemistry. So I majored in chemistry, and then I looked at my the course requirements, and it said I had to take like abstract like calculus and like physical it was like all these crazy math classes, and I was like, no, I like basic chemistry. This is talking about like crazy stuff. So I changed my major immediately to biochemistry. And so it was like that nice balance where I could do a lot of chemistry, but I wasn't doing like crazy, like high level calculus, because calculus is not even real math. That stuff is crazy. So I didn't want to torture myself like that. So I switched over. So anyway, back to this question. So I was a master at chemistry because I was a master at the periodic table. And for you guys who struggle in chemistry, that's right, rule number 1. So you went to lecture and you learned some words, but you didn't take the time to sit back before lecture, go through the material, and learn the periodic table. So we want to learn our fundamentals really, really sound. Then we go to lecture and we get added to. So electronegativity, what does it mean, right, to be electronegative? What's the definition? Give me your cookie cutter science definition. Electronegativities. I like how, you know what it is? See, I asked that question, people paused, right? So people paused because they were over there looking that up because you guys don't know. It's terrible. It's terrible. Electrons are hogged by an atom. Okay, so electronegativity. Electrons are hogged by an atom. That's almost a human definition. Okay. Samantha, high electron affinity. C. Charles said willingness to attract more electrons than another element. So all those definitions suck, I think. They're all right. You're almost there, okay? But if you had to remember that 15 years from now, you would struggle. So with electronegativity, this is how stupid I am, right? I create little stupid stuff like this for me to remember. Electronegativity is electronegative. Electro as in the electron. The electron is negative, so if I attract electrons, I become mass negative. So the way I remember electronegativity, 15,000 years from taking basic chemistry, is that it's composed of electron and negativity. So electronegativity is my attraction for electrons, which is going to make me more negative. So it's my propensity to get more negativity in my life. Electronegative. Electrons are negatively charged. My attraction for electrons makes me more negative. Does that make sense to people? Electrons, negative, mass negative. So that's for forever. You never lose that. So it's you're bringing in these electrons, making these electrons mine, and it makes you more negative. So you're wondering, are electrons negative? Well, I just told you they're negative because it's in the word. Electronegative. Right? Then, right, if all the question asked you on your homework assignment was, which of these is more electronegative? If you answered that question correctly and you moved on, all you would have an understanding of is this single word, electronegative. But what do people do on the test, right? They don't ask you which of these is more electronegative, right? And I had to look it up because I couldn't even remember all these words. They're going to ask you about what? The ionization energy. Oh, who remembers that? What is the ionization energy? What is that concept? Don't give me, Roberto said EA. What is EA? You don't even know what that means. Give it to me. Someone said energy to emit an electron. Come on, guys. Energy to remove an electron. Energy it takes to become an ion. Ability to release an electron. All right, we're getting closer. You guys are all right. But is that memorable, right? How are you going to distinguish this from this 15,000 years from now? All right, so the ionization energy, in science terms, is the energy it takes to remove an electron. Okay? The energy it takes to remove an electron from something. So, the way I remember ionization energy is the opposite of an ion, right, is the stable side of the periodic table, that far right side. So you're stable, you're balanced, you're electron, you're neutral, right? So your neutral element self. The ion side is a charge. So this is not scientifically correct, but this is how you can remember a science thing correctly, incorrectly. So I think of the far right as being fully charged and stable and all that kind of stuff, right? And they're going to be neutral. So I think of ion as a deviation from the far right side, meaning you had to lose an electron. So it's the energy it takes to become an ion. So it's the energy it takes to move from the far right off the far right. And so everyone knows, right? Everyone on the far right of the periodic table has a full electron ring. So if you move from the right to the next slot over on the left, what'd you do? You lost an electron. So that's how I, for forever, remember ionization energy. It's the energy required to become an ion when you would have been stable on the end. Even though it's not correct scientifically, it's correct in terms of how you would use the definition. Does that make sense to people? So it's a super basic way of understanding it that doesn't make actual science sense, but makes perfect sense in understanding the definition for the long haul of your life. Becoming an ion from a stable thing, so moving left on the periodic table. When we move left, we lose electrons, become more positive. So if we're becoming more positive, moving to the left, it's going to be the opposite of electronegative. So when I'm looking at trends on the periodic table, I know these two, right, will increase together because it's going to take more energy to remove an electron, the more that I want an electron. So I know they're going to go together. Like that, right? Electronegativity and ionization energy increase as you go up and to the right. Does that make sense? So now we took one question and we got two concepts out of it. Let me get a drink of water real quick. Does that make sense, everybody? Give me a like if you like that. Give me a like if that makes sense. Okay? So then we have these two things, right? The other concept the teacher's going to throw at you on the test is electron affinity. So electron affinity is how much you like electrons. The more you like electrons, the more you will like to take on electrons and become negative, the less likely you are to want to lose electrons and become an ion off the end. So 1, 2, 3. So if you took one question about electronegativity and you expanded it out, now you've got 3 concepts. And with those 3 concepts, you have a better understanding of the initial concept. Then you take all that stuff together, right, and you create the trend. So let's take a step back. I just lost my eraser that quick. All right. Everybody still with me? Okay, so you create this trend in your periodic table, up and over. Yes, up and over. Then, once we have that, we're gonna add layers to our understanding. More layers. So we just 3 concepts. Now how do we take those concepts and make them generalizable, make them applicable, and make them bigger than life? Well, we have the trend on our periodic table. So based on this trend, right, we have a bunch of elements here. So let's break down the elements so we can have a more deep and a more layered understanding of what's going on here. Well, why would electronegativity, right, and our affinity for electrons increase as we go up? Well, every time we go up, we remove a shell of electrons. By removing a shell of electrons, we expose more of our positive core. Okay, well, why would exposing our positive core make us attract electrons more? Well, in science, opposites attract. So that positive exposure is not shielded by that negativity anymore. And so therefore it's going to attract and bring in those negatives. Oh, that makes sense. Okay, in addition to that, because there's fewer layers and we just have smaller layers, that means that this positive core is going to hold on tighter to each shell the closer I get. Therefore, the electron is going to wrap tighter to our molecule. So it'll have a smaller radius. Oh, okay, that makes sense. That's another thing I heard about, something in class about radius of the sphere. And okay, and wait, and then we talk about these shapes in the s orbital and p orbital. Why do those orbital shapes make sense? Well, the stronger we pull on something, the more uniform the orbit will be. But if we have, right, weakness in our grip, right, when you guys are holding on to something, right, you're holding the bags, right, you're carrying grocery bags, and you're getting in the house, oh, right, you're doing this. It's, right, we're off balance, we have weakness. So the weaker you get, what happens to your shape? Right? What happens to your shape? It gets crazier and crazier and crazier. Crazier and crazier and crazier the bigger you get. Okay? Left to right. Okay, well, why does it make sense that we would attract more electrons going left to right? Well, our objective is to get more full. Okay, over here, we're closer to being full if we have more electrons or more negatives, so we're going to pull more negative on there. Additionally, wait, we said opposites attract earlier. Okay, so if I have more negative in my each rung, and I have all these positives on the inside, then every time I add a negative, I'm going to pull those tighter. So if I pull that outside tighter, my affinity for my electrons is stronger. So it's going to take much more energy to ionize me. Oh yeah, that makes sense. And then on and on and on and on. And you took one question and you turned it into a 15, right? We've been on here 40 minutes. You take one question and you turn it into a 15-minute dialogue with yourself at the table, and you're going through it like this. And if you do that with every single one of your problem questions, could there ever be a moment where you're confused? Is anybody else doing that in your class? Nope. So as a result, you know more than them. And then furthermore, you've gone beyond the scope of just the basic understanding. And so you're going to go above what the average student is doing. You're going to get above the average. You're going to break the curve. And you're going to dominate your tests. That's how it goes, guys. It's not super complicated, but it's all those things. First thing, setting yourself up with the proper mindset. That's why we do Med School Motivation Mondays. Get our mind right. Having a seeking of understanding, not looking for the grade. The second thing, we're going to prepare for our lectures, getting our fund of knowledge strong so that way we can get at the examples that the teacher's giving in class. Then, after lecture, we're going to do more problems than anybody else. We're going to do harder problems than anybody else, and we're going to take the easy problems or any problem, and we're going to expand them out and do elaborative interrogation and turn them into bigger learning, grander learning, deeper learning of all the concepts, weaving everything together. That's how you do it, guys. Does that make sense to everybody? If that makes sense, you give me a like right now, give me a comment, let me know that you understand what I'm talking about and that was useful to you. So, this is important. And this is the last thing I'll say, and then we'll get to your guys' questions. But it's so important, guys. Everything is not equal. And it cracks me up all the time because all you students are so obsessed with time and the time quotient of studying. And if you guys have seen my Instagram or you guys are in my MCAT course, you guys know that I said your MCAT score is equal to your time spent, right? And this is where most of you guys focus. Well, how much time should I spend on the MCAT? How much time should I spend? Oh, I need to spend more time studying, more time studying. And you forget that the other side of this equation is quality of time. And so you ignore the quality part and you guys all focus on time spent, and what you're left doing is studying and studying and studying and studying and studying time and time and time and time and time. But if you shift your focus and figure out how to make your time much more valuable and make the quality of your time better, then what happens is we'll block Tuyo or whatever. I haven't seen what he said, but I know Roberto, so if Roberto said Tuyo needs to stop, I'll just block him. Make it easy. By the way, did you guys notice that our racist friends who were calling me the N-word on here have disappeared? I'm happy about that. I don't know if the FBI got them or if they just kind of wised up and said, hey, listen, it's probably, not the best thing. These are people who are trying to be positive, and let's get our negativity out of here. But anyway, so quality of time spent. Getting over here and focusing on the quality. And so what I just kind of went over with you guys is how you can maximize, right? How you can, small tips for improving the quality of your time. And so the reason my course is, so I mentioned, right, Yesenia wrote an MCAT review for me. My MCAT course, my 5 pillars course. So my 5 pillars of studying course is called the 5 pillars of studying less and getting better grades. So a lot of people say, well, that's impossible. Well, it's not impossible because we take the focus off the time spent and we do quality of time. So by magnifying our quality of time, the time spent goes down. And so I encourage you guys, if you're not going to take my courses, fine, but learn to focus on the quality of your time. How am I studying, not how long am I studying? And if you focus here, you're going to have happier pre-med lives because you're going to have more time for your friends, and you're going to have higher test scores because nobody else is focusing on this. It'll be just you and the people who are in my courses. So, all right, so that's all I have to say about that. If you guys don't know, my website, premedproductivity.com, premedproductivity.com, and you guys can see my thumb here as I scroll through all you guys' questions. Oh no, guys, it's doing that thing again. It's doing that thing where it got rid of all you guys' comments. So if you asked a question really early on, please ask it again because it's getting rid of questions from the beginning. So Carlos Rivera asked, any tips for biochemistry? I have it next semester. So Carlos Rivera, that's a tip right there. My other tip would be take one of my study courses. There's tons of tips in there. Or just watch my other YouTube videos. There's other tips there. But biochemistry in particular is kind of a hybrid between biology and chemistry. And so you kind of have to use both tactics of memorization and also of arithmetic. But you got to go beyond it and be active in all phases. And so using a similar framework for that kind of class. So C-Charles just asked, it went away, should you take biochemistry 2 before you take organic chemistry? So you guys should know my philosophy on taking different prerequisites or getting to prerequisites, right? It's not about the grade, it's about the knowledge. So in terms of how biochemistry relates to organic chemistry, I don't think you need the biochemistry. I think you should actually take organic chemistry first would be better because then you learn about what organic molecules are and how things are affected. And then in biochemistry, you learn the real applicable kind of narrowed down clinical foundation and cell foundation that actually you're going to want to know for long term. So I would say OChem first and then biochem, but they don't really matter. And so this is another example. So someone asked, what residency am I in? And someone asked, what medical school did I go to? So if this is your first time, I apologize for poo-pooing on you. But if this is not your first time, then shame on you because I constantly get on people about their lack of thoroughness. So people will email me, and this is no joke. People email me and say, hey, listen, I was on watching YouTube videos, and I was just wondering, what school did you go to? Or, what's your specialty? And I'm like, oh, and I just delete the email immediately. So if you send me that email and you haven't heard back to me, then I delete your email. Because it means you're not thorough. Because if you go to my website, I have an entire bio on there. You can learn everything you could ever want to know about me. Right? My social media is pretty transparent. My channel is pretty transparent. We talk about it all the time. So if you have any questions, and this is even funnier. If you just go to the description box, in most of my description boxes, I say I'm a Stanford Medical School graduate. I say that I'm an anesthesia resident. Right? So all these things. So pay attention. Pay attention. I hate the lack of thoroughness you young bucks have. So not thorough. Okay. So thank you, Chad, for informing some people on here. So Chad said I went to UCI and then Stanford. Thank you. So Madison said, do you have any tips? Oh, it just disappeared. With 5 courses and labs on top of that, how do you suggest we tackle additional homework problems? I feel as though I'm always running. So that's a good question, but this goes back to what I teach in my study course. You're overloading yourself. And I was just actually meeting with a coaching student on Monday, and we sat down for like 2 hours and some change. And one of the things that she does to sabotage herself, she's a very smart student, but she sabotages herself by saying, and some of you guys, maybe you guys say this, let me know if this is you, where you tell yourself, the more stuff I schedule, the more pressure I feel, the better I do. How many of you guys feel like, oh, I need the time pressure of being overly busy to be productive? Okay? Yeah, exactly. Some of you guys are putting that on there, okay? If that's you, it's the wrong mentality to have. It's the wrong mentality. You've got to go back and understand that the reason you need that time pressure, right? You need that franticness is because you're not motivated, you're a procrastinator. But there's a lot of reasons that cause that. But more importantly, guys, if you're struggling, so someone just asked a question, I'm taking 5 classes, a lab, and I can't find time to do the homework. You just answered your own question essentially, right? The solution to having 5 questions or 5 classes and a lab and not having time to do homework is to take less classes. Why would you take 5, well that's 6 classes, why would you take 6 classes in a term? For what? What is the function of that? How does that help you other than make you stressed out, make you not have time to perform, wreck your GPA, wreck your knowledge, which will wreck your MCAT, and destroy your medical school chances? Who are you helping? Are you impressed by your 5 classes, 6 classes? Because medical schools won't care if you don't have the grades in those 6 classes. Now, if you're taking 6 classes and you got all A's, that's impressive, right? Because they assess you on your course load. But 6 classes and all B's, I'm like, I'll pass. I'll take the kid who was smart enough to realize he couldn't take 6 classes and took 3 and got all A's. Score, I'll take that. Kyle, what is up? Does that make sense? So recognize, guys, like quit sabotaging yourself and catch a clue about what's happening. If you're overloaded, pull back on the schedule. There's no reason to take 6 classes in a term. It's ridiculous. Bro said, how about Motivation Taco Tuesdays? Well, the reason we don't have Motivation Taco Tuesdays is because I actually like Taco Tuesdays, so I don't want to be on here with you guys on YouTube on Tuesdays when I'm at Taco Tuesday. Recognize. This is SoCal living, y'all. Taco Tuesdays. All right, Chad, I'm glad you love the positive energy on here. This is what this channel is about, right? Premed Productivity, it's all P's. Premed Productivity is all about possibility, positivity, productivity, and pre-med, pontification, ponderance to non-pre-medness to physicians. Oh, that's under the P. So P. It's all about P's. That's what we're about on here. Excuse me. We are at 48 minutes, guys. We are rolling. So, Javon, new to here. Glad you're on here. Nice to meet you. Nice to meet you. Naomi said, do you have any content for incoming M1s? Woot woot. All right, M1, Naomi. I like it. I survived pre-med, thankfully, so I can relate to all of this as much. So people keep asking this. So I'm getting emails from you guys. I'm getting comments from you guys. If you're a medical student or you're starting medical school, right? So the material I present goes to all levels. So so in the past 6 months, I've taught studying to high school kids, college kids, M1s, the medical school, like first year medical students, how to survive in their classes. The M2s, how to do well in their step 1. The M3s and M4s, how to transition to clerkships and how to study during clerkships. I've also taught to residents how to study effectively in residency. So this is my whole point to you guys, what we're talking about today. If you have a sound fundamental base that allows you to maximize the quality of your time, in any study setting, if you can maximize the quality of your study time, it goes across the board. in medical school, the hardest thing, right, is it's information like a fire hose. So if you can be more efficient with your time and have high quality studying, then you can absorb that fire hydrant much more easily in much fewer hours, and you will succeed in medical school. So I teach stuff from my 5 Pillars course all the time to medical students, to residents. So if you're a medical student and you're not in my 5 Pillars course, you're going to suffer the consequences in your medical school. All right. So I don't even know what that says, the giraffe symbol. Krizik says, hello, this is my first time I have actually interacted with you. Oh, I just lost the comment. So Krizik, you're going to have to say it again. I didn't get it. Incoming Premed 2001. Tiffany, hello. Let's see. All right. So this is so Chad, you had some nice stuff on here, but you also have some stupid stuff. So this is like Tui was saying, that stuff is easy. So you guys crack up and you guys say that kinematics is easy and that the periodic table is easy. Okay? So then why are you guys having to restudy chemistry and physics for the MCAT? Because you thought it was so easy the first time you took it, and you didn't take the time to learn it like I learned it, right? Like I was just showing you there. Oh, that's easy. That's kinematics. Oh, that's easy. That's the periodic table. And you overlook these small deficiencies in your knowledge base and in your understanding, and it screws you up when you get to more advanced stuff. So I love to see those kind of comments because it shows, right? And this is the arrogance, the false arrogance that students have about their studying ability and about their knowledge, their fund of knowledge that they don't recognize. When you go to study for the MCAT, what are you studying? Kinematics. What are you studying? Periodic table. When if you would have just learned it well the first time, your MCAT studying would have been that much easier. Instead of assuming you know it in its basic stuff, right? It's why people struggle in geometry because they didn't learn algebra. They're like, oh, I was great in algebra, but I suck in geometry. No, you suck in algebra, but you got by. You got the grade, but you didn't know algebra, so when you got to geometry and you had to take that algebra and apply it to shapes, you got exposed. It's the same thing, guys. It's the same exact thing. And to say that the periodic table in kinematics is basic, I use the periodic table all the time as an anesthesiologist. I use kinematics all the time as an anesthesiologist. So for example, so I said I haven't been sleeping much. 2 nights ago, we put in what's called an Impella device into a gentleman. An Impella device okay? This is your heart. It has 4 chambers. Atrium, atrium, ventricle, ventricle. Okay? Left ventricle pumps out to the body via the aorta. An Impella device is a big tube with a sucker on the end. We go into the artery, shove it into the aorta, into the left ventricle. It sucks blood that's oxygenated from the lungs, from the left ventricle, out the left ventricle, and then pumps it to the body because the left ventricle has failed and can no longer pump. Well, why can't it pump? Well, because flow is based on delta P. So if this ventricle can't generate significant pressure to overcome your hypertensive, high blood pressure patient, then you get heart failure and blood backs up in your lungs and you die. This gentleman could not generate any pressure because he had a heart attack and his heart couldn't pump and generate enough pressure to overcome the delta P. We put this device in, it sucks fluid at a certain velocity to deliver it at another velocity to determine a blood pressure in the patient. So in order to set that Impella, I had to use a kinematic equation and literally say, okay, if this is the initial velocity here of the blood, and I need to get it to this velocity to translate because delta V, delta P, right? Everyone remembers that, P over V, yeah? You have to understand how fast you're sucking here and at what pressure to generate what velocity and what pressure here to generate this person's blood pressure. So to say kinematics is basic in junior high, you're an idiot for saying that, and that's why you're suck at chemistry and physics, because you think that basics don't go on and beyond. Additionally, I had an old guy just this morning, and I had 2 choices to reverse his paralysis. Okay, I paralyzed this guy for the procedure. To reverse paralysis, right? So our muscles have these nicotinic receptors and they're cholinergic, right? Everyone is familiar with acetylcholine, right? So the cholinergic receptors to act on that receptor. I have the option of 2 medications, glycopyrrolate versus atropine to reverse this guy. I chose glycopyrrolate because glycopyrrolate Get it? Is more electronegative. And by being more electronegative, it becomes more negative, it becomes charged, it doesn't cross the blood-brain barrier, therefore it won't make this guy loopy and crazy. Because it turns out acetylcholine is necessary for brain function. And so old people who have dementia and all these kind of things, they take medications that boost their acetylcholine in their brain to help their dementia. So if I were to give him atropine, right, and the way you remember atropine is making people crazy, you think it's mad as a hatter. So if I would have given this guy atropine instead of glycopyrrolate, he would have gone crazy and had a crazy paranoid episode. But instead of giving glycopyrrolate, and the only reason I know that is because it's more electronegative and it overflanks the atropine, doesn't cross the blood-brain barrier. So, I ask you guys, when you guys sit through undergrad and say that undergrad has no relevance to clinical practice, it's because you don't understand what clinical practice is. And the reason I chose anesthesia is specifically because I get to use all that fun math and science from freaking junior high, as he said it was. Junior high. Does that make sense? Okay, so pay attention and don't tell me it's junior high. It's not. All right, so let's get back at it. Okay. So Javon said, a lot of professors would tell us we don't need to learn that. Should we go rogue? You should go rogue. So you guys know this is a rogue channel, right? We do things differently than every other channel, than every other student. We're blazing our own trail, therefore we're having different, better results. That's what we're trying to do over here. Currently a third-year medical student. Any tips for surgery rotation? So William, yes. So similar thing, right? Surgery rotation, about being efficient with the knowledge. So you're learning a whole new knowledge base, how to survive in the operating room and about procedures. You have to have efficient ways of going about studying all the material. So be efficient. And again, focus on the quality of your time you're learning and not just spending tons of time in the OR blindly. Focus on what you're doing in the OR and actually making your learning active in the operating room. Let's see here. Sorry, guys, I have to scroll through these questions. So, Kasim, I'm glad you're getting these concepts of 2 years of chemistry. So simple to understand. I'm liking it. I'm liking it. Yes, Carlos Rivera. Yes, long live. Premed Productivity. Yes, I'm with it. Samantha said you should totally do more of this, like a weekly explanation of certain topics in all of your free time. Yeah, definitely. Yeah, no, negative. All right, let's see. Gonna kill it in biochemistry now. Love it. Yes, do kill biochemistry. In case you guys don't know, if you're just popping on here while I scroll through these and find the next question, on Monday on my Facebook, Med School Motivation Mondays, got a great talk for you guys. Get on there, Facebook. So Yesenia wants me to talk about my journey to medicine a bit. I think that's a topic for a whole other video. I'll actually do a video. For one of the Med School Motivations, we'll talk about my journey to medicine and kind of what you can get from it and what to expect from your journey to medicine. I think that's, right, it's part of your mindset is knowing what to expect and being comfortable with your expectation. And I think someone else will email me this week asking about talking about they were told that they shouldn't go into medicine because it's not a great, the future looks bleak for doctors. And that's also something I'll talk about in that journey to medicine. And we'll talk about how long that journey is, how hard that journey is, how rewarding that journey is, and then also the end game and how it is when you're actually a physician, is it all worth it? So that'll be something, not this Monday, we'll do it in 2 Mondays from now. So that'll be our second Med School Motivation Monday. I'll talk about my journey through medicine and then how it's, more importantly, is how it's applicable to you guys and what you should expect in your journey. All right, let's see here. Thank you guys for all your questions. I really appreciate you guys being on here and asking questions and engaging with me. If you guys are still here, feel free to like this video. We're at 59 minutes. You know what's funny too is you guys clamor for information, and then when I do these long live feeds, I can see, like, it's hilarious that people will watch and then they just like sign off after like 10 minutes. And it's like, okay, you got an hour of goodies on here, and then you'll email me about something we just covered in the other 50 minutes of this video. But hey, people are not thorough. And if you're on here long enough to watch all this, then you are thorough. And that's why you'll be better than them. So what can you do? Sorry about my finger. Sorry, my finger's all on the screen there. So Dominic, you're welcome. Yeah, I don't know why people want to get on here and be negative all the time. I don't get it. I don't know, like, they spend the time on here, so they're on here for an hour. Like, why would you spend the time watching this? If you don't enjoy it, why are you here? How do you do more practice problems? So Pat asked, how do you do more practice problems while doing less and being more efficient? So just like that, Pat. So it's not about doing less problems, right? You do more problems and you spend less time in the totality of your studying by making each moment you spend with those problems worthwhile. So by making every minute you spend with something quality, like we did there where we take one problem and we make it 10 problems, that's how you actually can study less, because you're going to get way more efficient with each problem you do. Yes, so exactly right. So Jesse and Jeremy said, 5 Pillars course is amazing. Everyone should take it. You absolutely should. Cool. Derek said, tips for big research papers. So Derek, last week, so we did last 2 weeks on here, we did research and how to find research, I think we talked about, and then also how to, we talked about how to find research, how to thrive in research, and I think we didn't quite get there, but I have a thing coming out about how to get published in 30 days. I think that's what you're talking about, research publications, so be on the lookout for that, how to get published in 30 days. Man, you guys I love it. We're talking up a storm on here. For those of us that are going back to school, so Jamar asked, for those of us going back to school for pre-med after earning a degree with little natural science courses, this makes me so much more confident. Jamar, I'm glad this is making you confident. I'm happy for that. Thank you. And Kasim, yes, my website is the best on the internet. I agree. Teach PKA. You must be crazy. Actually, wait, did we talk? We talked about PKA on our webinar. We got on a live webinar. Someone asked about PKA. I think we talked about equilibrium and reaction stuff on the study webinar on Sunday. So yeah, doing target practice problems based on material that keeps popping up at Pat. That's what I believe. I don't know what that was in regards to. Are your courses videos or interactive? So my courses are both. So my courses are videos, right? Getting your fundamental knowledge, and then we come together in the form of webinars, and we take it to a higher level. So that's how it works. So you get your base core knowledge from the actual recorded videos. Then we get on webinars. You get to ask questions similar to this, but we spend more time on each individual question. And then we also expand on those topics doing more. So for example, last Sunday in my study course, right, you get the 5 courses, but then we did a webinar, and I taught an hour and 45 minutes of an entirely new way to read more efficiently, because people wanted to know how to read better. So boom, we did that, and it was interactive. People got to ask their questions, so it was great. Okay, so Christine says, what is the best way to tell a school like Georgetown that you want them without sounding desperate? Well, my question to you guys is, does it matter if you sound desperate to a medical school? What's the difference between desperate and hungry? What's the difference between desperate and hungry? Kasim said, so I love my students. Kasim said work, exactly. When you're desperate, that means you're begging for something that you don't deserve. So you're going to medical school like Georgetown saying, hey, listen, I know I have a 1.1 GPA and my MCAT score is 5th percentile. I've never done research. I've never volunteered, but I'd love to go to your medical school. Please take me, please take me, please take me. That's desperate. That's Loserville. But now, if you put in the work and you create an exceptional application and then bring that to them and say, listen, you're where I want to be. I've worked hard to fulfill all the things that you want in an applicant and more because I want to be here. I want to be here. Take me. That's hunger. That's desire. That's passion. And that's the difference. That's the difference between desperate. But you can never be too thirsty if you do the work. So Basic Book Nerd asks, will I be offering a back-to-school discount for the 5 pillars? So guys, this is something that comes up, so I guess I'll address it now, but I'm also doing another video on this. But so my courses, so there's 2 questions. Let me answer 2 questions that I get. The first one I get is people will email me and say, hey, listen, your MCAT course was $99, now it's $179. That's not fair, I want it for $99. And I tell people, I say, listen, I reward people who are hungry and who are on it and who get to it. The early bird gets the worm. So whenever I release my classes, guys, they will never be cheaper than when they're first released. And that's why you can always feel good about getting it when you get it. So some people got my MCAT course for $49. 49 bucks. Hell of a value. At $179, it's still a hell of a value. However, it's going to be $179. So you can say, okay, well, $179 is more expensive than $99, but $179 is 10 times cheaper than what you would pay for an inferior course at one of those big companies. And I'm telling you this because people who are in the MCAT course are telling me it's better than all those big companies. It's $179. If you can't suck up and pay $179 when the opportunity, right, the other cost is $2,000, then what's the problem? So don't be upset that my early birds, the people that move on stuff, got it for $99. Those are my people, right? They've been on here. They know what's up. So if you were coming on late or you were like, oh, I'm unsure, but now I want it, it's $179. Deal with it. Get it. It's still well worth the value. Guaranteed. Okay? It is what it is. Same thing with my study course. People get asking for a discount. Why is your study course $450? That's so expensive. Oh my gosh. Is it? How much would you pay to be able to study less and get better grades? How much would you pay to be confident in the classroom? How much would you pay to be able to fire your tutor? How much would you pay, right, to be assured that you're going to deliver in the classroom and on your MCAT to get to medical school? So what's $450? How much do you spend every quarter in tutoring? Every year in tutoring? In extra books you never read? In stress, right? What is stress worth to you? So $450, right? So teacher, I said parseless. $450 is nothing because it's life-changing. So if you could change your life, $450, you would do it. And that's how you guys don't look at it. That you look at, oh, $450, oh, but you'll pay $2,500 for an MCAT course from one of those companies. But you won't pay $450 for a study course that's good for your whole life and everything you ever do in study. Anyway, so my whole thing is guys, when I release something, when I first release it, it's the cheapest it will ever be. So I say, listen, guys, I'm releasing this course, and it's just coming out, jump on it, because it will never be cheaper, and it's way undervalued. So, and then Jake said, I don't have $450 or $2,000. I'm sorry. That's why I offer one of the pillars for $65. If you can afford that one, you can get in there. But I can't, again, give it away for free because I also have to, it costs me money to host these courses. People think, oh, it's just free, it's magic. No, it costs money for me to provide these courses. So anyway, I'm going to get out of here. We've been on here a long time. If you had questions tonight and I didn't get to them, we went on over an hour, get at me. Send me an email and I'll get to them. But thank you guys very much for being on here and getting at the courses. I thank you very much. I will see you guys Monday for Med School Motivation. I am out.